As we do projects with AV or microcontrollers, we find ourselves making a few basic routine connections to some of the microcontroller pins in every project before we add the rest of the circuitry to the microcontroller. In this tutorial, I want to talk about such routine pin connections of the ATmega328P microcontroller. In this example, the ATmega328P microcontroller is powered from a 5V voltage regulator. Pin 7 is the digital power supply and pin 8 is the ground pin of the microcontroller. Connect the VCC pin to the positive terminal of a regulated power supply and ground pin to the power supply ground. Add a 0.1 microfarad ceramic capacitor between VCC and ground for noise decoupling and place this decoupling capacitor close to the microcontroller IC. Leave the reset pin unconnected. Reset pin is active low, which means a logic low voltage applied to this pin will reset the microcontroller. Therefore, to prevent accidental resetting of the device, this pin is pulled high internally. We can easily measure the voltage at the reset pin. Here I am supplying power at 5V to the VCC pin of an ATmega328P microcontroller. And the voltage at the reset pin is 4.77V, which will be considered a logic high by the microcontroller. So, by leaving the reset pin not connected to anything, we are not keeping this pin floating. The reset pin is pulled high with an internal pull-up resistor that connects the reset line to VCC, and the value of this internal pull-up resistor can be anywhere between 30 kΩ to 60 kΩ. Which is quite a high value for a pull-up resistor. Using a high value pull-up resistor compared to a pull-up resistor of lower value causes more voltage drop across the pull-up resistor, resulting in reduced voltage at the reset pin. This is the reason when we measured the voltage at the reset pin earlier, we got only 4.77V, which is quite a bit lower than the VCC voltage. This is called a weak pull-up, and for very noisy environments, this internal pull-up might be insufficient. We can improve this situation a bit better by adding an external pull-up resistor. 10 kΩ can be a good value for a pull-up resistor. Here we measure the voltage at the reset pin again after adding a 10 kΩ pull-up resistor from reset pin to VCC. A 0.1 microfarad ceramic capacitor can also be added from reset pin to ground for additional noise immunity. However, this capacitor needs to be disconnected while using debug wire. All general purpose input-output pins of the microcontroller have protection diodes to both VCC and ground, but in the reset line, the diode connecting to VCC is not provided internally. So a diode can be added from reset pin to VCC to protect the reset pin from electrostatic discharge. Adding the ESD diode should be a consideration if you are designing for a commercial product or working on a special project where the reset pin might undergo an ESD event. But for people who are just starting out learning electronics or doing hobby projects, there is no need to add the ESD protection diode or even the external pull-up resistor or the capacitor to ground. Leaving the reset pin unconnected should be fine for most projects. These three pins connect to the analog to digital converter of the microcontroller. AVCC is the supply voltage pin, AREF is the reference for the analog converter, and pin 22 is the analog ground. Connect the analog ground to the power supply ground. Connect AVCC directly to VCC or to the power supply's positive terminal. AVCC must not differ more than 0.3V from the digital supply voltage. AVCC needs to be connected to VCC even when the analog converter is not being used. Add a 0.1 microfarad ceramic capacitor from analog supply pin to analog ground pin for noise decoupling. And as we did on the digital side, place this capacitor close to the microcontroller IC. For projects requiring very high conversion accuracy, AVCC can be connected to VCC through a low-pass filter to prevent noise from the digital side permeating to the analog side. Place a 0.1 microfarad decoupling capacitor from AREF pin to analog ground pin if the analog reference is being used in your project, otherwise leave this pin unconnected.